Hi, in this video, I am going to go through and finish the cleaning exercise that I began to demonstrate on Tuesday of fall 2023 for Bio 321G. So this is just opening up a clean version of the notes I'd sent out on a computer that does not currently have gplots installed. So first thing I'm going to do is I'm going to install gplots, install.packages, gplots, so we'll be using that later on in the code. Okay. Once that's happened, you can modify this setup WD in order to work within whatever directory you want it to be working on inside of your file system. Instead, though, what I'm going to do is I am just going to utilize this little drop-down menu, and I'm going to select, you probably can't read that, to source file location. When I do that, it actually writes the piece of code for me, which you'll note that I kind of use a similar naming scheme across my systems, but there is a slight difference, and so that previous version wouldn't have worked on my current computer. Once I've done that, this updates my working directory down here, and so that's going to modify where all of this stuff is taking place. So at this point, I will now run this URL and the file1, which is going to allow me to download the file using that information. So this is the code downloading the file. Okay, I was worried for a second. I can look at the head. I can see that this is a tab separated this is a comma separated value table. I could look at the tail. We'll see that there's some weirdness going on at the end of the script file, or at the end of the file. In the end, though, I just need a read.csv file to read this purportedly CSV file. At this point, though, I would definitely want to still check things and just make sure that it had been imported well. Just scrolling through, I'm not really seeing any issues, but there is some weirdness. It's a little bit hard to see on my current screen, so a great option to allow you to view the data for reasonably sized data is the view function. That is with a capital V. Produces a sortable, interactive view. It's quite handy. Here's the original order. We can see that there was some mess down at the bottom. A dot here, I think a dot here. Nope, that was dirt on my screen. So this is empty. Maybe it has a space. Yeah, it looks like it has a space. I can kind of, I don't know if that's going to show up via the encoding for this video, but there's a space here, which I can kind of see if I highlight it with my cursor. But over here, I can't. And so those are actually empty. So there's two types of missing data, an empty character, a space, and then I said there's two, but there's a third one here that is the dot, and then there's a fourth one that's an NA. So we have a total of 4 different types of missing data within this object that we need to account for. Okay, so the next section says to rename the object. I gave you this code to rename it. This is extracting the current names of the object, then constructing a list of, or a vector of better names, assigning those values, and now if I call the column names, I can see they're different. And if I print off the object, I can see that they're different. That is one way that we can assign to a function. Only a subset of functions have that property, usually things related to attributes or extractions. This next one is just giving you a demonstration of how we can use order. This is a very handy piece of script. I use this constantly. But the tricky thing with order is that it produces a vector of like what you would want to extract in order to do the ordering. Use the word order in my definition here. The positions you would like to extract that would result in the order being as defined, if that makes sense. And I could use this in all sorts of ways. I could use this to rearrange some of these original objects by themselves, but here I'm using it to rearrange the entire data frame based on row. It's very much like a powerful strategy tool. There is whole packages built around this concept that have many different functions that essentially are just all using this in clever ways. Learning to use this right away is much more powerful. It gives you the flexibility. That's why I choose to teach it that way. Now, once I run that, that does change the order because you can see I've reassigned it to the original object. If I come over here, it's actually already refreshed. This is its current order, I believe. Yeah, so it's not filtering because it was already sorted. The row names are the actual names. A data frame is created with row names that are just the positions by default. So those are traveling with the original data, which is very handy, actually. So the next section was like just part of the cleanup process is you've got to handle missing data. So we had a number of different types of missing data. This one is just replacing it within best color. I believe we could have done this across the entire data frame instead, had we wished. Let's see what this produces. Nah, that one doesn't work. What if I take out the which? I feel like I've done this before. This is probably not working because it can't be coerced into a matrix since it is multiple types. Actually, I guess it's not multiple types today. I'm not sure why this isn't working. It's because I'm using percent and percent. If I did this one thing at a time, if I did this one thing at a time, I could assign to each of these, which can be like a perfectly valid strategy. But in reality, I only really needed to work on this one column, and so this was the strategy I took. But like I said, it is just purely strategy. These 3 lines do it for the entire data frame, what this does for one column of the data frame. So what's desirable, it's really dependent upon your needs. In this case, the reason I am making these in A is because like these are student data points that I can't handle. They represent not really erroneous, but just confusing data. And so I think they should be removed. But that's part of this data cleaning process that just requires you to be a little strategic and go in with a plan. So in this case, my plan is I want to be able to create a pie chart of the different colors that each person likes in this class. At this point, I can't do that until I remove values that are not like representable within this pie chart that I'm creating. So as much as I like the solution, sparkles and rainbows, I can't represent that on a pie chart that has like wedges colored those shades, unless I did a lot more work and made sparkles and rainbows part of my image. That would have been fun, but a little beyond the scope of this example. So there is one solution that was whatever you think is the best color here, and then there was one that was quoted. And that quote will actually prove to be an interesting challenge. The table function is just a really handy way to tabulate the different values that are present within a vector. All right, so all I've done was just kind of break down and add some white space to help visualize this answer code that I'd provided. What I'm doing is I'm creating a vector of the quoted version, whatever you think the best color is here, and then a version without the quotes. Note the backslash the backslash quotation marks, which is defined as an escaped quotation mark. Because I am communicating directly to R here, I only need one backslash. Turns out percent and percent will use that appropriately. Unlike with grep, where I needed 2 backslashes because there was 2 layers of interpretation. It's a subtle difference. So at this point, I create that object. I then create a logical vector by taking each of those values and then finding where they're present within my data. They just happen to all be next to each other because of the sorting. If I check this extraction based upon that logical vector, I can see it correctly identified those values. And so I then assign it the missing value. If you visualize it now, I lost my cursor. If I visualize it now, I can see that those values have now been removed. If I call table, I can see that those values have been removed as well. So the next section was for like G-sub practice, so I'm just going to scroll through that for now. I'll come back and make a separate video for the questions. At this point, I am loading this gplots library. This is going to allow us to convert certain values into hex code. So you can see a few messages, including a warning message that this was built for the next version of R. So my current computer is slightly behind. That's fine. It should probably work. I am creating a empty column. So there was some values in that column already because I gave you a version with it a little bit complete. I've removed those values just for demonstrative purposes. This is me creating a column in order to be filled. My hex logic is going to extract a vector of color information and see if it's inside of this column. However, in order to do that, I would need to have remembered to go scroll up and run some of this code. So sorry, I'm not going to have time to redo this. So just bear with me. I forgot to run this section up here, which was like having a place to modify. I don't really want you modifying right into the original data because it makes it hard to work backwards. And so my general suggestion is create a new column. It's easy to just keep adding columns. You can always remove them if you don't want them anymore. But if you overwrite the original data, it's hard to figure out what went wrong because stuff goes wrong. So that's like why I made Bentley mod instead of just Bentley. So if I visualize StuDF now, it's just got the same data from best color, but it's in a new column called cleanDF. That's the one we're going to work on. I then say write code to clean the following so that the below describes the unique values. Replace color equals tags with or without the space and quotation marks. So I wrote a pretty complex line of code. We can break that down fairly easily though. I can see three total substitutions that are occurring. I'm going to start from the left to the right. Ooh. That's just finding actual quotation marks. And then this last one was removing spaces. Okay, so let's talk through each of these commands and make that a little bit bigger. It's a little bit hard to see. Okay, so what's happening here is that this first one is finding any character any number of times followed by an equal symbol. Now, surprising me at least, equal symbol, not actually a special character in GSub. And so it doesn't need to be //. Now, I probably tried it with I probably just tried it at first and saw if it worked or not. And then I would have added / if needed. But what this is going to do is it's going to remove anything before an equal sign. So no matter what like version of color, was it capital, was it lowercase, no matter if there was a space between color and equals or if they hadn't put a space. And then I even added a space followed by an asterisk. And so this means that that equal sign can be followed by 0 or many spaces. So that's going to effectively match this one and match this one at the same time, as well as a lot of these other colors. So if I run that line of code, and then just to make sure I don't get confused later, I go and replace these so that they are building off of each other. Let's go take a look at to see what that looked like. So here, having run that code, I can see the color is gone. In fact, all of the things that mention color are gone because anyone who put color also put that equal sign. They may or may not have put a space afterwards. But since I accounted for that, these all have been corrected. Now, what hasn't been corrected for is some of these contain quotation marks. Additionally, some are lowercase and some are uppercase, and one even has a space. It's not actually that bad of a problem, but it's something that we may need to be aware of. So this next one is removing the quotation marks. Literally a quotation mark. You can see that by this escape. So that means that this is going to pass it to R. Now you may be wondering, why am I not double this? And that's because quotation mark by itself is not a special character in GSub. So I don't need to communicate to it that, hey, there is a backslash here. I only needed to communicate that backslash to R. After running that, all of my quotation marks are still there. I do still have that space, which may or may not cause problems. I ask you to remove it. And I still have uppercase and lowercase. This is going to just delete that space. So now it just says olive green. And finally, this last one, and again, I need to adjust this so I don't overwrite my object that I've been working on, my column that I've been working on. Oh, sorry, that's just the redo. So we're good there. That was the one that just did all of that in one step. So finally, I want to get rid of those uppercase letters. So I'm going to run that one more time with 2 lower. And now I can see that these are all nice and pretty. If I sort them, that all looks good. Nothing's out of place. This is all making sense so far. All right. So the next thing that's going to happen is it's going to make it so that we can see some of the colors that are being printed here. So I just kind of gave you some handy code for manipulating strings. If you want the quick and dirty of it, it finds unique values. It sorts those values. Paste O connects to here. And what that's going to do is it's going to collapse them together with a apostrophe, comma, apostrophe. So it's actually putting these little apostrophes in there. Then I am catting it, which allows me to use special characters to change how it prints off, adding a line break so that it appears down here without like the number symbol that printing vectors would result in. And before I can do that, though, I am just kind of sticking on a little bit extra code. So I'm sticking that line break on, I'm putting on a C comma with a apostrophe, and I'm adding an apostrophe close parenthesis at the end. In the end, what I get is just this nice little piece of code that I can copy and paste, and that just allows me to quickly visualize what's working and what's not. This is a new feature. Actually, I love this new feature of RStudio that allows you to easily visualize what colors represent. And what we can see is mint and olive green don't have definitions. Okay, so that brings us back to where I was before, where I was creating a hex code column. Hex code is going to store the color data that is like better. This is just getting pretty complex, but I thought this would be fun to demonstrate for you at some point. Here are all the colors that I could have said. So I could go through here and I could just try to pick out ones that would make sense. Heck, I could use this code actually. And this would be pretty cool. Instead of do those colors, I could just do this color. Let's not sort it. I don't know what order it comes in. It's probably already sorted, but if it isn't, there could be some interesting sorting in there. Just checking my parentheses. That looks pretty good to me, except that should go here. And there we go. All right, so now everything's matched up the way it should be. I could copy that And if you want to see what all of the different options are for you, here you are. Yeah, I'm glad I didn't sort that. So we can actually scroll through and see all of the possible colors now that have names. It's pretty cool. I've never actually done that before. Geez, it's a lot now. All right, I'm going to stop. This is fun, though. All right. So that's obviously too much to scroll through. So instead, the option that I took was I created a logical vector of if the names of those were in there. I could see that some are not, some are. I then go through here and I use what's called hex to code. Col to hex to pull out the values that are in the color options. I convert that to hexadecimal code, so that's a way of writing color names as well as just a way of writing like data. And if I now visualize that column, I can see here's where I had some missing information originally, so that didn't get converted, and here's where I had some colors and other missing information that couldn't get sorted. I then say, all right, well, I'm going to just go look up like different colors on a single guide. This is just more like trying to show you how I would go through some of these processes. Like I would say, all right, well, in my protocol, I'm going to say I use the HTML color guide and use the first hexadecimal value per page just to help standardize my protocol and minimize my internal biases towards like what's the best color. As if like there are multiple places, and I'll be honest, I only had 2 this year that I needed to look up. I usually have more. And so I used the HTML color codes because I thought the olive green and mint did match my interpretation of olive green and mint. But I will tell you that I went through a couple of pages where I was just like, that is a very weird choice for olive green and mint. And I just didn't trust them. So, I mean, in reality, you would probably want to use something like the Pantone colors, which is like a data set of like values that if I am talking to a graphic designer, it's what they use. I don't have money for that. This is just a free little stupid lesson. So I just went to this free resource. But in reality, like if I was doing a publication on color preference, I would want to use like a really well verified and like established data set for kind of interpreting things like this. Maybe even work with an expert or contact them and like, hey, I need like the most like the core concepts for these colors. And I would work from there. And so at that point, this is just me extracting the values from hex code based upon the values in clean color. Right now it's missing, but once I run this, I skipped it. Where is it? There it is. This now has 808000 in it. So I do the same thing with mint. I calculate an object of the table values, this time omitting missing information. I can see that there is some empty characters, and I think that's just because I never ran my empty character thing up here. So we'll just rewrite it down here. That's fine. We don't need to worry about that so much. So let's, before we calculate that table, anywhere this equals empty character, we're going to set equal to NA. Now, I said before, you have to be a little bit careful when doing logical, and here is why. You can see that my missing values, even though they don't equal empty character, they actually pulled out the NAs. And so that could cause a problem if, say, I was like filling this in with white or something like that. It won't cause a problem here, but it's why you often want to use which around logical extractions. All right, so now if I rerun this, those missing values those empty character values are now set to missing, so they don't pop up. I need a list of colors to use in this, so that's just me using a match function. Match will take these values and match them inside of this larger data frame. I am then using that position to pull out the corresponding position within hex code. So at 6, 7, and 19, I had black, blue, and green, which were the first 3 colors in my color table, just because it's been sorted already. So there we go. There are our colors. If I wanted to prove that to myself, I could go use that complex paste and cat function in order to visualize it within RStudio. But in the end, I can do that just as easily by visualizing my pie chart. And there you go. There is everyone's preference as listed, except for, unfortunately, rainbow and sparkles, because I would have had to do a lot more work to make that one work. So finally, I demonstrate a pretty handy piece of code, which is using gsub to strip off the end of the file name and then replacing it using paste O. You'll note, like, why didn't I use it with the replace? And the reason why is I've learned better. What happens is if I mess up on this right here, let's say I had a capital C, easy enough to make, and I had made my replacement here, the replacement wouldn't happen, and I would accidentally overwrite my original object. Very bad mistake to make, especially if you have trouble recreating that object. And so what I've done here is robust to the presence of me messing up, because it will always add on code. It just only correctly formats the ending if this gsub works correctly. Very handy little kind of strategy thing. So anyways, this is just me writing my final output. I could then go to Files, go to my working directory, view the file, and hey, there it is. If I was doing a little bit more, I'd probably remove these columns. So I can just show that real quick. So if this is missing, I don't want it at this point. So I've made it a negated search, so now it's returning true for where I want. I know that's not going to need a which because that's the purpose of is.not. It works around missing information. That one really doesn't need a which. And now I've just kind of created a spin-off version of my file called stewdfclean, since I was really deleting data, and that's always kind of dangerous. But now if I go and view that data, looks good, nice and clean. And there you go. That is like an overall cleaning process, something very realistic, working with human-generated data. You run across a lot of these problems in all sorts of data, but humans are wonderful and they often cause issues like this. So hope that helps. Thank you.